All right. This is lesson 13, and we're looking at what they call potential dangers when solving equations. It says describe the property used to convert equations from one line to the next. Okay, so basically we're just talking about the same distributive, commutative, associative, all those type of things. But we're just going to use it to talk about here. So we gotta look and see what's going on. This is our original. Okay. Now, what do they do on the bottom or on the one below it? Well, they distributed this x right here to both of them. Okay. So this is just distributed. Okay. Now, what did they do? X minus x squared, okay. Okay, they subtracted, or no, they added a positive x squared to both sides, okay, to cancel these out. So they plus x squared, I'm going to say to both sides. Okay. Okay, make an eye there. There it is. Now let's see what they did. Okay, they just combined like terms right here. They combined that x with that plus 2x, so we combined like terms. And this is not cutting it. This pen is not good. Combine, let's just call it combined terms. See if that'll work. There we go. Now, what did we do? Okay, we added 24, we added 24 to both sides. So we plus 24 to both sides. And what did we do here? We combine x's. Well, no, I don't want to call it combining x's. I want to say I minus or subtracted 3x from both sides. Okay. That's what's happened on that. So let's see here. What are we getting into here? In each step above, we applied a property. Okay. Why are you sure that the initial equation and the final expression 2 or 20 equals 5x? Why do we say that those are the same? Because what they would say is we used properties to rewrite the equation. And we know if we do it to both sides, we're fine. What is the common solution to all these properties? Well, the last one was 20 equals 5x. Go ahead and solve that. X equals 4. Solve the equation for x for each step. Describe the operation used to convert each equation. So what you're going to do here is talk about what you do each time. Okay. So we know we have to operate within the PEMDAS. All right. So that's definitely going to be what governs our actions here. Here we have brackets or parentheses, and we have parentheses inside the parentheses. But in this parentheses, we can't do x minus 1, but we can, inside the big parentheses, do the distributive property. So that's the first thing we're going to do. That's going to be negative 3x plus 3, because we distributed a negative 3 to all of it. So now we have still have a parentheses, okay? And now we can do commutative property, or what we would call we could do commutative property slash collect like terms. So we have like terms here and here. So that's going to be negative 3x. And the reason why we call it commutative property, because which way are you going to write it? Are you going to write the 11 on the left side or on the right side here? I like leaving my terms that have the x on the left side. So that's what we're going to do. And now what are we going to do? Well, we're going to do distributive property and distribute this. Remember, act like this is a negative 1. We're going to negate everything on the inside. So this becomes positive, that becomes negative, and we can get rid of the parentheses now. Now we're once again, I'm going to do commutative property slash combine like terms. These are like terms. Now we can subtract x from both sides. That leaves us with, we'll rewrite it over here, is 5x minus 11 is equal to a negative 19. We'll add 11 to both sides. That's going to be 5x is equal to a negative 8. Is that right? Oh, no, that's not right. I knew that wasn't going to be right. This should have been a plus down through here the whole way. My pen failed me again. So if I do that, that equals 30. So that, I like that better. So x is going to equal 6. All right, let's do another one. Do the same thing. I'm just going to talk you through it. I'm not going to write down everything that I'm saying here. That will take forever, especially with this pen. All right, we have to work within the parentheses. Inside that parentheses, we have more parentheses, or inside those brackets, but we can't do anything except for do distributive property. So 4x minus 3x plus 4. That's going to be 7x minus everything inside that is going to have to be negated eventually. Okay. So we can go ahead and combine these terms. This 4x minus 3x, so that's just going to leave us with x. I'm going to rewrite it over here. 7x minus x plus 4 equals x plus 12. I'm going to pause this for a second and try and wipe my screen down. Okay. Now let's see if that'll write a little bit better. Okay, so now what can we do? Well, we can distribute this negative 1. Remember, I said you can always put a 1 right here when there's not one there. So let's distribute that negative. 7x minus x minus 4 equals x plus 12. That's 6x minus 4 is equal to x plus 12. And now we can add 4 to both sides, and that's 6x is equal to x plus 8. Subtract the x, and we got 5x equals 8. I don't know if I like that or not. Nope, I don't like that because Mr. Anderson didn't do it correctly. Let's try it again. We would add 4 to both sides, and that is 16. Equal to 16. So if I subtract x, this will be a plus. Subtract x. What am I doing wrong here? I still don't like that. It's 5x equals 15. That's not going to divide evenly. I'm messing up somewhere. Or have I messed up? I messed up in the very beginning, didn't I? I did. I messed up right here. This should have been a 3, not a 4. So this should have been a 3, which I made this a 3, which made this a 3, which I made this a 3, and I've added 3 to both sides and got a 15. I like that better. So 5x divided by 15, x equals 3. Let's do that. I didn't figure they'd have even too many of these as a fraction, so let's use that. Sorry about that. All right, once again, let's do a appendix. We got a bunch right here. A lot of parentheses, lots of brackets. Okay, I'm going to do this. This would be 6. 2 times 3 is 6 minus 10x plus 4. All that's 2. So I combine that and get 10 minus 10x times 2. Okay, I'm just working on this side of the equal sign right now, which is going to make this 20 minus 20x. Okay, now I'm going to come over here and I want to erase this over here first. Erase all this, and I'm going to work the other side of the equation sign as far as I can. Okay, so what's going to happen whenever you have a bunch of distributive property stuff, you probably just need to work it out as far as you can and then try to work across the equation, or I'm sorry, across the equal sign. So now then I'm going to pull this over here, move this right here. That would be 5 times 6 minus 6x plus 2. Okay, and this is still inside the parentheses. So let me go ahead and do that first. That would be 8 minus 6x times 5. That's 40 minus 30x. So now I'm going to set these equal to each other. And let's move up. Since this is the biggest negative, I'm going to move it to the other side, which gives me plus 30x plus 30x is 10x. Let's move this 20 to the other side is equal to 20x. So x is equal to 2. Okay, so there that is. Now I'm going to have to erase all this again. This is good why y'all should be taking notes, is because all this stuff is going away. Therefore, you're not going to be able to see it anymore on this whiteboard if you go back to look at it. You need to be taking notes as you go. Okay. Now then, this last problem here. I'm going to start out doing distributive property and say, what's half of 18? That is 9. Ooh, what's half of 5? I'm going to say negative 5 halves. And a third of 6 is 2 minus, or what's a third of 4? Well, I don't know, so I'm just going to leave that's 4x over 3. Now, I can go ahead and move the 2 to the other side by subtracting 2. That's a positive 2, so I'm going to subtract 2. And that gives me 7 minus 5 over 2x is equal to 4 over 3x. Now, we would move this to the other side. This 5/2 to the other side. So that's 4 over 3x plus 5 over 2x. Because I can't do that yet because I don't have a common denominator. So if I make this into a common denominator and add it together, my common denominator is going to be 6. 3 times 2 is 6. So 4 times 2 is 8x plus 2 times 3 is 6. So 3 times 5 is 15 over 6x. 7 is equal to 23 over 6x. I really do not like that either. So let's see here. What am I going to do? Let me see if I've done something wrong here. I don't see anything. That would be positive. So if I divide 23x divided by 23 over 6, I would say 7 over 1, change my sign, that's 6 over 23. So that's 42 over 23. And that's not divisible. So let's see why. I know y'all are loving just going straight through your homework, no messing up. But see, I've taught Algebra 2, I've taught math for years, and I'm still messing up. So don't think you're able to should be able to fly straight through this. So here's another way we could do this. We could look at this as all divided by 3, and this is all divided by 2. So to do this, we can multiply this side by 3. Those would cancel, which means I would have to multiply this side by 3. Okay. Well, guess what? We're going to do the same thing over here, multiply by 2 for both sides to get this to cancel. And so I can multiply this side by 2. So let's do that. And that does away with these because we've divided that. So let's do distributive property. What's 3 times 18? That would be 54. So this would be 54 minus 15x, because we got to distribute 3 all the way. And then let's do 2 times, that's 12 minus 8x. So now that we've got rid of everything there, just about, and I don't want a negative x, so let's go ahead and add 15x, add 15x. That would give me 7x. Let's move this 12 to the other side by subtracting it. So that would be 42 is equal to 7x, divide by 7, divide by 7, x equals 6. There you go. That's how I would do that one. That's some fancy work in there. All right, what else is next? All right, consider this. The equation is x plus 1 equals 4. And x plus 1 squared equals 16. Verify that 3 is the solution to both equations. Well, that should be fairly easy. Because 3 plus 1 equals 4, check. 3 plus 1 is 4, and 4 squared is equal to 16. 16 equals 16, so that's check. Okay? So that's how you would do that. Just plug it in and answer. Find a solution. Okay. Let me show up here. I messed up my screen whenever I erased it. Find a solution to the second equation. So the second equation is x plus 1 squared is equal to 16. All right, this has, so find a solution to the second equation. Well, we already found one, so now let's find another one. Okay, we said that 3 would be 1. So what else can we find here? Well, if we do the square root of both of these, we end up with x plus 1, because the square root and the square cancel each other, is equal to the square root of 16, which is 4. So we would say x plus 1 equals 4. Subtract 1 from both sides, x equals 3, right? Now, here's the cool part. Whenever you have x plus 1 equals the square root of 16, that's plus or minus. We use the plus 4 here. So now you have to use the minus 4. So the negative 4 times the negative 4 is 16. So if I was to say x minus 1 plus 1 is equal to negative 4 minus 1. So if I do the minus 1 to cancel these out, I end up with x equals a negative 5. So there's your other solution. There was the first solution. Here's the second solution. All right, let me go to. Based on your result, what effect did squaring both sides of the equation have to appear on the solution? So the new equation seems to retain the original solution and also a second solution. So since it was squared, we have 2 answers. And that 2 answers come from it being a positive square root and a negative of the square root. Okay, so that always remember, whenever you have plus a square root, you also have a minus square root. All right, page 8. Consider the equation x minus 2 is equal to 6 minus x, and x minus 2 squared is equal to 6 minus x squared. Did squaring both sides of the equation affect the solution set? Well, no, it didn't, because 4 minus 2 is equal to 6 minus 4. That's 2 equals 2. So if I square root both sides, I still have x minus 2 is equal to 6 minus x. So it doesn't affect it. It goes back to the exact same original answer, or the original problem, actually. All right, based on your results, does the answer in part C of the previous question need to be modified? Well, no, because it retains the original solution. All right. So no, it does not need to be modified. It's not squared or anything like that, because we ended up square rooting it. Consider the x cubed plus 2 is equal to 2x squared plus x. Verify that x is equal to 1, x is equal to negative 1, and x is equal to 2 are each solutions to this equation. Okay, so this, it gives us the x's, so all we have to do is plug them in. So 1 cubed plus 2 is equal to 2 times 1 squared plus 1. Well, 1 cubed is 1 plus 2. 1 squared is 1 times 2 is 2 plus 1. So yeah, we know that that is equal to each other. What about negative 1? Negative 1 cubed plus 2 is equal to 2 times negative 1 squared minus 1. So negative 1 times negative 1 is positive 1, times a negative 1 is a negative 1. So we're going to have negative 1 plus 2 equals, well, negative 1 squared is positive 1. So 2 times 1 minus 1, 2 minus 1 is 1. So we have the same thing. 1 equals 1. All right, what about 2? We have 2 cubed plus 2 is equal to 2 times 2 squared plus 2. 2 times 2 is 4, times 2 is 8 plus 2. 2 times 2 is 4, times 2 is 8 plus 2. We know that's going to equal. That's how you show that those are solutions. All right. Now then, oh no, what am I doing here? Sorry. Okay. Bonzo decides to apply the action, ignore the exponents on each side of the equation. He gets x plus 2 is equal to 2x plus 3. In solving the equation, what does he obtain? What seems to be the problem with this technique? So if we just do that, let's just solve it now. We have x plus 2 is equal to 2x plus x, which gives us 3x is equal to x plus 2. Subtract x, we get 2 is equal to 2x, divided by 2, divided by 2. 1 is equal to x. So we still get one of the solutions, but we don't have the other two. That is the only option for it. So no, it is not a good technique because you don't get all of the solutions. What would Bonzo obtain if he applied his method to the equation? Okay, so all that's saying is if we ignore the exponents, that would leave us with x plus 4x plus 2 equals x. Well, that would give us 5x plus 2 equals x. So that would give us, I'm going to move this over here. I'm going to subtract x, that's 4x plus 2 equals 0. Move the 2 to the other side, that's 4x is equal to negative 2. Divide by 4, x equals a negative 1/2. And no, that is not an answer to the original solution or to the original question. All right, let's look at some more. We got a lot of questions on this one. Consider the equation x minus 3 is equal to 5. This says multiply both sides of the equation by a constant and show that the solution did not change. Okay, all this is really making me mad because we're just doing the same thing over and over and over again. So this would say x minus 3 times, let's go with 4, is equal to 4 times 5. That's all the same. So what if, now it says multiply both sides by, I wonder if this wants me to use the original. I think we'll just use the original here. X times 5, okay? It doesn't change anything, right? Because we could divide both sides by 4 at the top, and we can divide both sides by x here, and it doesn't change anything, okay? It's the exact same thing. So what about this? Show that x equals 8 is the solution to the new equation. Okay, so we had x minus 3 is equal to 5x. So plug in 8 for each one. Now, got parentheses, let's do it first. So that leaves us with the same thing. That's as far as we got to go because we know those are going to equal. Okay. Let's see here. Show that x is equal to 0 as a solution to the new equation. Well, we know that if we multiply anything by 0, that's going to give us 0. So both of these are equal to 0. Now, if we multiply each one by x minus 1, okay. Now, is this going to change anything for us? No, it's not going to. And I bet it's going to say, now prove it on the next problem. Show that x is, okay, so we got the new solution. 8 minus 1. And then it was x, which was 8, and then x minus 3. That is equal to 5 times x minus 1. So when we do that, this gives us 7 times 8 minus 5. And we have 5 equals 5 times 8 minus 7. Same thing. Both of those are the exact same thing. Well, if 8 was the same thing, 1's going to be the exact same thing. So I'm not going to work that out for you. Just plug in 1 every time you see an 8, and it will work out. Okay. Let's see here. Based on your results, what effect does multiplying both sides of an equation by a constant have on the solution? It has no, it does not affect it at all. If you do it to both sides, it doesn't affect it at all. Based on your results, nothing. Based on the results, or based on your results, what effect does multiplying both sides of an equation by a variable factor have on the equation? So if we multiply it by a variable factor, it will give us additional solutions, right? And so that was the x squared. When we multiplied that by x, we got x cubed. So that's going to give us more solutions to it. Okay. All right. That should be enough for your to answer your homework questions. And I don't think there's all that many, but that is it for this video.